So, Math 3, this is the continuation of the review for 2A and 2B. So we got clear up to 13 in the last, and so now we're dealing with this rational stuff. So the first couple are just simplifying rationals. So, to simplify, remember, we need to have the same on the top and on the bottom. And we have to be careful about things being added. So, can we simplify this at all? Well, 28m and 16, do they share anything? Well, 28 is like 4 times 7 times m. 16 is like 4 times 4. So I can pull a 4 out, right? And have 4 times 7m plus 4. Over 8 is like 2 times 4. Now, this 4, because we're multiplying, can cancel out with this 4. This 4, however, cannot, because it's got this plus 7n. It's like a package deal. You can't get rid of it. Okay? So this is as simple as I can make it. So I get 7m plus 4 over 2. Okay, now number 14. The thing to remember with adding and subtracting, we have to have common denominators. So I try to simplify these denominators. 2v and 8, 8's like 4 times 2, I can pull a 2 out. So I really have 3 over 2 times v minus 4 plus, now can I simplify that? Yeah, 4 is like 2 times 2 over 2v. I can eliminate a 2 and have just 2 over v. Okay? Now to get a common denominator, I'm going to have to multiply, aren't I? Okay? So the left side, I'm going to multiply both sides by v. That'll give me 3v over 2v times v minus 4. The right side, I'm going to have to multiply by 2 times v minus 4. The whole shebang. Okay? So then my denominator ends up being the same. So then we're just adding the numerators. So 2 times 2 would be 4 times v minus 4. Distribute the 4, and we'd have 4v minus 16. Now, can we combine 4v and 3v? Yeah, so we'd end up with 7v minus 16 over, and I could distribute that and have 2v squared minus 8v. I can't simplify it further, so there's my ugly answer. Okay, with subtraction, same idea. So, can I simplify that? Yeah, I can pull out a 2. So I'd have 2 times 3n plus 1, and then just 3. So did that really help me? Not really, so let's not even bother. So the right side we times by 3n over 3n. So 3n times n gives us 3n squared minus 3n times 4, 12n over 3n times 6n plus 2. The left side we multiply by 6n plus 2 on the top and on the bottom. So on the bottom I get 3n times 6n plus 2 and a minus, and then on the top 4 times 6n, 24n, 4 times 2 plus 8. So I have common denominator, so my common denominator of 3n times 6n plus 2 over, then that minus kind of applies to both, so think of it as plus a negative 3n squared plus 12n. So there's no other, so we go negative 3n squared plus 12n and 24n would give me 36n plus 8. Now what we have to try to do is see if we can simplify this to eliminate anything. Which, if we think about this, negative 3 times 8 would be negative 24. Are there any factors of negative 24 that would add up to 36? I can't think of any that would work to do that. So we can't do it. So that we could leave as our answer. Of course, they may end up having us, if this were multiple choice, they may distribute that 3n and have a denominator that's 18n squared plus 6n. Same thing, but just be aware sometimes they like to mix it up like that. Okay, now with multiplication, much easier to deal with, okay? Because we don't have to find common denominators. We just think of it as one fraction, and we simplify. Now, 10x minus 10, we can pull a 10 out of that, right? So we'd have 10 times x minus 1 over x plus 4 times x minus 1. Now we have a package deal, or battle buddies, on top and bottom, so we can eliminate those, and we're left with 10 over x plus 4. And that's our answer. Okay? Now, number 17, simplifying, same idea. Okay? So this one I can pull out a 5 and an m. So 5m times, we'd have m left over plus 3 over, then we try to simplify that. Factors of negative 48, that would be positive 2, 6 and 8, if the 6 is negative. So x minus 6 times x plus 8. Okay. And I'm not seeing anything we can simplify here. So I was hoping that something would happen, but nothing is, so that's really as simple as it gets. Okay? Sometimes you'd hope that they'd end up that we could, eliminate something and we'd end up with something more simple like we did here, but in this case it seems to not be what we got. So there we go with that one. Alright. Now division works the same way. Okay, they try to fool you with looking like that. It's really like this. And remember, when you're dividing fractions, you can't, so what you do is you multiply by the reciprocal. So instead of 1 over a minus 7, it's a minus 7 over 1. Then we simplify. Well, 8a and negative 56, I can pull an 8 out of that, right? So I get 4 over 8 times a minus 7 times a minus 7 over 1. So a minus 7 on top and bottom, they eliminate. 8 is like 4 times 2, 4 on the top and the bottom, they eliminate. When nothing is left on the top, you leave a 1, and the only thing left on the bottom is a 2, because 2 times 1 is 2. So we simplify that to 1/2. So that one worked out really nice, didn't it? Okay, now let's take a look at solving rationals 1920 and radicals 21, 22. Okay, 23 and 24 pretty simple. It's just a solution of the system, so what do? We graph it. So let's hurry and just knock those ones. So for 24, that's not 24, hold on. Here's 23. So we type them both in, and then you see where they intersect, either using Desmos or graphing calculator. Graphing calculator, remember you have to hit menu, analyze graph, and then click on both either side. But there's our 2 intersection points. So that's the solution to this system. You write down those 2 points. And the same thing for 24. Write in your equations. Got a linear, a radical. That's where they intersect. That's our answer. That's what you write down, that point. Okay, so when you're given those systems of equations, pretty simple to deal with. Now, the cool thing is 22, 21, 20, and 19 can work that same way. Okay, so I'll show you that after. Using a calculator, you can graph and make it into a system and find out where they intersect to help you find your answer. First, I'll show you how to do them by hand, and then we'll take a look at using the calculator to do them, okay? So we're almost done. Now, I quite didn't have enough time, and I did number 12 wrong in the last video. I gave you the summation, which was 312, okay? It wanted the expansion. What that means is you take this and expand it out. So I'd go 2 times 5, and then our first number is 1. 1 minus 1 plus 2 times 5. Then we go to 2 minus 1 plus 2 times 5. 3 minus 1 plus 2 times 5. And then we stop at 4 minus 1. So 1 minus 1 is 0. 2 times 5 to the 0. 5 to the 0 is 1. 2 times 1 is 2. Okay. 2 times 5, 2 minus 1 is 1. 5 to the first is 5, 2 times 5 is 10, plus 2 times 5 to the 3 minus 1 is 2, 5 squared is 25, 2 times 5 is 50, plus 2 times 5 to the third, because 4 minus 1 is 3, okay, gives us 2 times 125, which is 250. That's the expansion. You leave it like that. Okay, if we added it all up and it wanted the summation, it would be 312. But when it asks for an expansion, that's all it wants right there. Okay? So now back to these last problems, right? Alright, so the idea here with solving rational equations is you find the common denominator and then you multiply by it. So I've got p squared as one of my denominators, and I've got p. So if I times by p, am I going to get rid of this p? Yeah. Will it get rid of this one? No. What if I times by p squared? It'll get rid of this one and this one, because p squared is p times p. So then I times every piece by p squared, because we're using the multiplication property of equality. I don't have to times the bottoms by it. So those cancel, leaving me with 5. Those cancels, leaving me with 1. P squared, one of them cancels, leaving me with 1 times p, or p. So p plus 1 equals 5, subtract 1, we get p equals 4. Okay? Now, another way you can deal with these kind of problems is treating them like a system of equations, like we did over here. Okay, we turn them into two equations. So you take one side of the equation, and then you split it from the other side. Okay, the thing is, if we're going to use a graphing calculator to do this, or Desmos, we have to change the p's to x, but it works the same way. Okay, so we create two equations, we graph them both, and then we find where they intersect. Okay, which I have one of those, so let me grab it. So here's the graph. So see how I split them up, put x's in for p's, set them both equal to y. We get these two rational functions. Okay, now where they intersect, I take that x value and only the x value, and so x equals 4, which was what we already found out. Okay, so there's two ways you can attack those problems, which makes it nice, because sometimes they're pretty lengthy and the graphing calculator can help us out. So if I wanted to graph this one, I'd graph that left side by itself, I'd graph the right side by itself and get this. So I graph both of these. Okay, see how I split them up? This is the orange, this is a black. I see where they intersect, and so my answer would be 0.833, which probably is some sort of fraction, and when we do it by hand we'll figure that out. Okay, so that's an easy way to do it. So now let's do this one by hand. Okay, so common denominator, I got v squared minus 16. Now if you remember from those notes we have, which I don't have on this slide, it was if it's a squared minus b squared, we get a plus b times a minus b, one of those identities. Okay, so here v squared minus 16 is like v squared minus 4 squared. So I could simplify that to v minus 4 times v plus 4. Now the reason I want to do that is to realize that this v plus 4, if I times by v squared minus 16, I'm going to get rid of those like that and just have v minus 4 left over. Okay, that's the idea here you wanted to have. So I times by v squared minus 16 to everything, realizing that this is actually v plus 4 times v minus 4. Okay, so the v plus 4's cancel out, 1 times v, 1 times negative 4, v minus 4 on the right side, v squareds cancel out, negative 6v minus 6, that negative applies to the whole top, so I put it in parentheses, v squared minus 16 cancels out, and I get v minus 3. Then we simplify. Okay, so negative 6v, so v minus 3 minus 6v plus 6 equals v minus 4. If I subtract v from both sides, those v's cancel, leaving me with just a negative 6v. Negative 3 plus 6 is a positive 3 equals negative 4. Subtract 3 from both sides, we get negative 6v equals negative 7, divide by negative 6. and I get v equals 7 over 6, which if we plug into a calculator, this actually comes out to 1.16 repeated, which was different than our 0.833, and I realized why. I put a plus on my equation. So let me hurry and graph that again. This time I'll actually do it correctly. So you've got to be careful, because a small mistake like that will cost you a lot. Okay, make you think you have a completely different answer, especially if they say, well, maybe that's the mistake they're going to make, and if it's multiple choice, it makes that mistake for you, so you think you got it right. So you've got to pay attention, okay? I didn't pay attention, and look what it cost me. Okay, ended up screwing up my whole answer. So I'm typing it into Desmos right now. And let's see what that does for us. Okay, just looking at it on my screen. Okay, now things are going to work out. So let me hurry and take a screenshot of this, and I'll show you guys what I mean. Okay. All right. All right, so here's what we should have ended up with graphically. Okay, when I typed it in correctly, then we get the 1.167. Now remember, we only go for the x value. We're not trying to solve for the y. We're not looking where they intersect in the sense of a system, because we don't want the whole point. We just want the x value. That's all we care about. Okay, that we're just solving for x. All right, now the radical equations might seem easier to solve by hand. We can treat them the same way we did graphically as well. Okay, so in order to solve a radical, we need to get the radical piece by itself. So I'd subtract 6 from both sides. So 10 minus 6 would give me 4. So 4 equals square root of 16 minus 4v. Then we square both sides. 4 squared is 16 equals, squaring a square root undoes it, 16 minus 4v. Subtract 16. We get 0 equals negative 4v divided by 4. And 0 divided by 4 is 0. Oh, negative 4 is still 0. So v equals 0. Now, if we decided to do this as a system, we'd go y equals 10 for one of our equations, then y equals the other side. Okay? Graph them both, find where they intersect. 0, 10. So our answer for x is 0. So we can do this 22 the same way. Take the x plus 2, y equals x plus 2. Take this. So anytime you have an equation that you're solving for x, you can split each side up to y equals that, graph them, and then the x value is your answer. So this one, our x value answer is negative 1. So let's do it by hand and see if we can get the same thing. And we are nearly done here as well, so that's good too. So first thing I need to do, I've got the radical all by itself, so I'm going to square both sides. Okay, now x plus 2 squared, okay, we're going to basically, that's, x plus 2, so x squared, 2x, 2x, 4. Or it follows that pattern, a plus b squared equals a squared plus 2ab plus b squared, which gets us the same thing. So we have x squared plus 4x plus 4 equals, those cancel, 2x plus 3. Now I subtract 2x from both sides, and I subtract a 3 from both sides. So I end up with x squared plus 2x plus 1. Okay, now that equals 0. So now what I could do to solve is I could graph this, find the zeros, and those zeros would be possible answers. Okay, because it's squared, it means there's probably 2 answers. But we only had 1. That goes back to, once you get an answer, you plug it back in, and sometimes if it doesn't work out, that means one of them isn't an answer. You could also factor this and realize factors of 1 are 1 and 1. Add them together, that's 2, so we get x plus 1 times x plus 1. Okay, so in other words, this has a multiplicity of 2. So both of them would give you negative 1, so that's our only answer. You can plug it back in to see if it works. Okay, so if you had 2 separate answers, you would need to plug it back into your equation to see if it matches up. And we get 1 equals square root of negative 2 plus 3, which is square root of 1, which square root of 1 is 1. So it does work. Alright, so using those notes, using the calculator, here's an example of every type of problem you should see on this. So good luck.